Hello everyone, this is John with Siptopia.org. Today we are going to talk about a rather confusing topic, the timers in session initiation protocol. We will start with an analogy and try to divide the timers into three groups. This will simplify the concept a lot. Then we focus on client timers for invite and non-invite requests, followed by server timers for invite and non-invite responses. Finally, we'll put all these into a table to demonstrate how we can easily remember these timers going forward. Apparently, 3 is a magic number is an old song. We are using it here as the title to stimulate your neurons so that you will remember what the number 3 signifies in this tutorial. 3 is the types of timers in session initiation protocol. You might have seen a truckload of timers from A to K in RFC 3261. So where the heck does this tree come from? It is rather intimidating seeing all these timers in RFC 3261 and trying to understand them all. Well, we can put them all in 3 groups and simplify the concept. By the way, this whole SIP thing makes me hungry. Earlier I called Pizza Hut to order some food. My first call got dead air, so I hung up and called them again. Well, once again I got dead air. This kept happening until my patience ran out and I gave up. After thinking about alternatives, I called Domino's Pizza and forgot all about my experience with Pizza Hut. If you noticed, there are 3 types of timers that played a role in my story. One, since I was not getting any response, I kept redialing Pizza Hut. Naturally, my consecutive calls were made with perhaps seconds or minutes difference from the prior call. The difference between my calls is a timer. 2. After all those calls, my patience ran out and I gave up. My patience here is equal to the time period from the first call I made to the moment I gave up. This is another timer. 3. Once I was ready to move on with my life, I forgot all about Pizza Hut. The time it took for me to give up on Pizza Hut and forget all about the experience is the last timer in our story. To put these in more session initiation protocol friendly way, 1. When do I repeat a message? 2. When do I give up? And 3. When do I forget about it? Let's see if we can apply this principle and divide SIP timers into 3 groups. Before we move on, please note that we are focusing on a SIP environment where the transport protocol is UDP. While some of these timers apply to SIP environments with TCP, most of them do not. When you have TCP, you rely on the network and not on the SIP structure. Client request timers. As we all know, SIP is a client-server based protocol. There is a client who sends a request and there is a server who responds to the request. In this section, we'll look into client request timers. What were the questions we used to divide the SIP timers into 3 groups? 1. When do I repeat a message? 2. When do I give up? 3. When do I forget about it? Since there is a 3-way handshake involved in invite request, we'll look into one example with invite and another with a non-invite request. Let's start with client timers for invite requests. Folks, this is the topology we will be using in this tutorial. As you can see on the left, Tarzan is in California and he is using a SIP proxy / registrar in California. On the right, Jane is in Texas. She is using a SIP proxy / registrar in Texas. And in the middle, we have a session border controller that faces both sides. So we are going to start with a successful call to make sure our setup works. Here in this Kali instance, Kali Linux instance, we have a SIP client for Tarzan, also running a Wireshark capture to capture all the SIP traffic regarding these calls. and on the right we have another SIP client that Jane is using. So let's go ahead and call Jane. Alright, it's ringing. As you can see, we're also capturing the data. So let's answer the call and see all the SIP message exchanges. Let's go ahead and hang up and also see the buy request. Let's stop the trace and go through these SIP messages. The first SIP message is an invite request from Tarzan to Tarzan's SIP proxy. Tarzan's SIP proxy then sends a 100 trying response indicating that it is trying to process the invite request. Then it sends the invite request to the SPC interface facing California, and the SPC now sends a 100 trying response to the SIP proxy indicating that it is trying to process the call. And next we are seeing the call going out on the other side of the SPC to Jane's SIP proxy. Jane's SIP proxy in return responds with a 100 trying, indicating that it is trying to process the call. Then finally Jane's SIP proxy sends the call to Jane. Jane's phone responds with a 100 trying, followed by ringing, and that ringing response is relayed from the phone to Jane's SIP proxy, from Jane's SIP proxy to the SPC, from SPC to Tarzan's SIP proxy, and then from Tarzan's SIP proxy to Tarzan. A few seconds later, Jane answers the call, triggering a 200 OK response from Jane's phone to Jane's SIP proxy, from Jane's SIP proxy to Session Border Controller, and from Session Border Controller to Tarzan's SIP proxy, and finally Tarzan's SIP proxy sends the 200 OK response to Tarzan's phone. Since the invite request is a three-way handshake process, after the 200 OK response is received, Tarzan's phone sends an ACK request back to the same route that it receives the 200 OK from. So the ACK request goes from Tarzan's phone to Tarzan's SIP proxy, from Tarzan's SIP proxy to the Session Border Controller, from Session Border Controller to Jane's SIP proxy, and from Jane's SIP proxy to Jane. So this was a successful call, and these were the SIP messages that were exchanged. In order to simulate our first scenario, we are going to turn off the Texas SIP proxy. Keep in mind, Jane is using Texas SIP proxy, which talks to an SPC in the middle, which in return talks to this California SIP proxy that Tarzan uses. Now we are powering down this SIP proxy and running a test call while also capturing everything in Wireshark. So as you can see, the invite requests started being resent, and there's a pattern here. You can see that the reattempts take longer than the previous reattempt. In other words, consecutive periods are not the same. Now let's stop the trace and take a look at what we captured. So obviously the call started with an invite request from Tarzan to Tarzan SIP proxy, which in return sends the call to the SPC in the middle. Now the SPC tries to send the call to the Texas SIP proxy. Since we powered down the Texas SIP proxy, this invite request doesn't get a response. So what does the SPC do in this situation? It waits for 0.5 seconds to send another invite request. Then it waits for a second and sends another invite request. After waiting for 1 second and sending the invite request, it didn't receive a response, so now it sends the invite request after 2 seconds. So we started with 0.5 second period between the two attempts. We went to 1 second, 2 seconds, now we are going to 4 seconds. After 4 seconds, the SPC waits for 8 seconds to send the next one. After 8 seconds, it goes to 16. So obviously there is a nice pattern here. The periods start with 0.5 seconds and doubles in every attempt. Now we also see a cancel request coming from Tarzan C proxy. That's the answer to the other question we have been asking. When do we give up? So we have a C proxy that send the invite request to the SPC, and we have the SPC sending this invite request. So if you look at frame number 1067, that's the invite request that the California C proxy sent to the SPC. Now after 32 seconds later, the same C proxy sends a cancel request. Now why did we not see this from the SPC? The C proxy started its timer before the SPC to determine when to give up. So if I start a timer in the C proxy and then I start the same timer on the SPC, obviously the C proxy's timer will trigger first. Just for the fun of it, let's change the timer on the SPC and see what happens if the SPC's timer to give up the call kicks in before the C proxy's does. So this is where you configure the timer that we have been talking about that determines when to give up. Let's change that from 32 to 30 and see what happens. Alright, so Tarzan calls Jane. Now we are seeing the invite request repeated one more time. There's nothing new here compared to the previous test call. The periods are the same as expected, but again now we are expecting the SPC's timer to give up to trigger first. In other words, we are expecting the SPC to give up first. So look, here is, let's stop this trace. So let's take a look at these messages. We start with an invite request from Tarzan phone to Tarzan C proxy, which in return sends the invite request to the SPC, and then the SPC sends it out to the Texas C proxy that Jane uses. And at this point everything is the same as the previous test call. Now you can see the next invite request is sent out about 0.5 seconds later. The following is sent out about a second later. Then it turns into 2 seconds, 4 seconds, 8 seconds, and so on. So now you see the request timeout response coming from the SPC back to the C proxy. So the SPC's timer kicked in before the C proxies, and the SPC told the C proxy that the call is not going to complete. Naturally, the C proxy forwards the request timeout response to Tarzan phone. Client timers for invite requests test results are: 1. When do I repeat a message? If you do not receive a response to your invite request in 0.5 seconds, send the invite request again. Now double the timer here. If you do not receive a response in 1 second, send the invite request again. This goes on and on with attempts after 2 seconds, 4 seconds, 8 seconds, and so on. This period is the timer A. In other words, timer A's initial value is 0.5 seconds, then it becomes 1 second, it becomes 2 seconds, and so on. Will this go on forever? No. We have a limited patience. 2. When do I give up? When you send an invite request, you start timer B, which is 32 seconds by default. when you see all these recent invite requests based on timer A going out, you wait until your patience, aka timer B, runs out. 3. When do I forget about it? Now, once timer B kicks in, you start timer D. Timer D is 32 seconds by default, and that's the time it takes you to forget all about this call. Flush the call down the pipes. Naturally, unless you're a developer, timer D might not be too important to you. In the client timers for invite request, you should know about timer A and timer B. Now let's use register request to test the client timers for non-invite requests in our lab environment. In order to simulate the next scenario, we are going to mess with Jane's SIP client. So instead of registering to the RFC proxy, we are going to configure the SIP client so that Jane would try to register to a bogus IP address. And in a second, we'll start seeing the register request send out from Jane's SIP client. Similar to the invite request, the register requests have a pattern here. They start with a 0.5 second difference, then it turns into 1 second, then it turns into 2 seconds, 4 seconds, but look, it continues at the 4-second level. So unlike the invite request, once the first timer reaches 4 seconds, it just stays that way. And when does the SIP client give up? If you look at the difference between the first and the last register request, it's once again the magic number 32 seconds. Client timers for non-invite requests test results are: 1. When do I repeat a message? If you do not receive a response to your register request in 0.5 seconds, send the register request again. Now double the timer here. If you do not receive a response in 1 second, send the register request again. This goes on with attempts until 4 seconds. This period stays at 4 seconds at this point. Therefore, the repeated attempts are now made with 4 seconds in between. This period is the timer E. In other words, timer E's initial value is 0.5 seconds, then it becomes 1 second, then it becomes 2 seconds, and 4 seconds. If there are additional attempts, the value of timer E stays at 4 seconds. Will this go on forever? No, we have limited patience. 2. When do I give up? When you send the register request, you start timer F, which is 32 seconds by default. When you see all these recent register requests based on timer E going out, you wait until your patience, aka timer F, runs out. 3. When do I forget about it? Now, once timer F kicked in, you start timer K. Timer K is 5 seconds by default, and that's the time it takes you to forget all about this registration attempt. Flash this experience down the pipes. Again, unless you're a developer, timer K might not be too important. In the client timers for non-invite requests, you should know about timer E and timer F. Moving on to server response timers. The questions remain the same. 1. When do I repeat a message? 2. When do I give up? 3. When do I forget about it? Let's start with server timers for invite requests. Alright folks, in order to simulate this scenario, we are going to run a test call from Tarzan to Jane, and we are going to leave it in ringing state while we take down the California SIP proxy that Tarzan is using. This way, when we answer the call on Jane's side, we will see the 200 OK responses going out, but they will never make it to Tarzan's SIP client. Therefore, we will never see ACK requests coming back to Jane. Now, if you look at the 200 OK responses here, you see the same pattern that we have seen so far in this tutorial. And just like in previous scenarios, after 32 seconds from the first 200 OK response, we end up tearing down the call with a buy request. Server timers for invite request test results are: 1. When do I repeat a message? If you do not receive an ACK to your 200 OK response in 0.5 seconds, send the 200 OK response again. Now double the timer here. If you do not receive an ACK in 1 second, send the 200 OK response again. This goes on with attempts after 2 seconds, 4 seconds, and stays at 4 seconds if it reaches. This period is the timer G. In other words, timer G's initial value is 0.5 seconds. Then it becomes 1 second, and 2 seconds, and 4 seconds. And it stays at 4 seconds if you still need to repeat your response. Will this go on forever? No, we have a limited patience. 2. When do I give up? When you send a 200 OK response, you start timer H, which is 32 seconds by default. When you see all these resent 200 OK responses based on timer G going out, you wait until your patience, aka timer H, runs out. 3. When do I forget about it? Now, once timer H kicked in, you start timer I. Timer I is 5 seconds by default, and that's the time it takes you to forget all about this call. Flash the call down the pipes. Now let's take a look at server timers for non-invite requests. Server timers for non-invite requests test results are: 1. When do I repeat a message? Never. If you are a server, you respond to a register request with a 200 OK, your job is done. There is no ACK message you are expecting. This is not an invite transaction. When do I give up? Never. Well, since you are not repeating the response, you cannot give up on something you are not doing. 3. When do I forget about it? You do, however, forget about it 32 seconds after you send the final response, and that's the timer J. Now this is the table that summarizes the timers we have discussed in this tutorial. Well, you might be asking yourself, what the heck happened to timer C? Why is it not in this table? Before we answer those questions, let's run another test call in our setup. Let's take a look at timer C by running another test call between Tarzan and Jane. In this case, as you can see, we let Jane's phone ring, and that ringing message goes all the way back to Tarzan's SIP phone. So what happens if we keep this call in ringing state? I'm going to fast forward certain items so that you don't have to wait too long. A minute later, we see the 180 ringing messages exchanged again. So we waited for another minute and got the same messages. Let's take down the Texas SIP proxy and cut this message exchange and see what happens if the entities are not receiving these ringing responses. As you can see, we cut the communication, so there is no ringing messages exchanged at the 1 minute mark. So 3 minutes later, we see these cancel requests. Now, what does this tell us? This tells us that the timer C is used by SIP proxies, back-to-back user agents, and similar entities to make sure a call is still active so that they keep allocating their resources, and the default value of timer C is 3 minutes. Since this is a timer on the SIP proxies and not the end points, it's not a part of our main discussion. This concludes our tutorial on session initiation protocol timers according to RFC 3261. If you have any questions or comments, please let us know.